So today we're going to learn how you can find a missing angle in a right triangle. In order to do this, you have to use your calculator. And we did look at questions before where we were given the sine, cos, or tan of an angle as a decimal, and then you have to go backwards to find the angle. I did show you how to do that on your calculator before. Remember that the calculator has to be in degree mode for this to work. And if you're told that the sine of A is a decimal 0.8649, excuse me, and you want to know what angle A is, this is where our sine to the negative 1, cos to the negative 1, tan to the negative 1, which is above, they're above the sine, cos, and tan keys. That's where they come in. So if the sine of an angle is 0.8649 and you want to find out what that angle is, you have to go sine to the negative 1 of that decimal 0.8649 in your calculator. And that'll tell you what angle A is. So we go second function, sine, to get sine to the negative 1, because above the sine key is our sine to the negative 1 function, of 0.8649, 0.8649, enter, and if we round that to the nearest degree, that would be 60 degrees. 59.87, which rounds to 60 degrees. So A equals 60 degrees. That's the angle that when we take the sine of it, you're going to get 0.8649. Now, if you just do sine of 60, you're not going to get exactly 0.8649 because we rounded our answer to 60 degrees. If you want to get 0.8649, take the sine of the entire decimal, the previous answer, and you'll get exactly 0.8649. If you just take the sine of 60 as a check, you'll get close to 0.8649, but not exactly, because we rounded the angle to 60 degrees. But that's how this is done. If you're told what the sine, cos, or tan of an angle is, and you want to find out what the angle itself is, you use that second function key. So for question B, if the tan of B is 0.1288, and you want to find out what angle B is, we have to go tan to the negative 1 of that decimal, 0.1288. And that'll tell us what angle B is. So second function, tan of 0.1288. And so that angle is 7.33928, and there's more decimals there. But if we round that to the nearest degree, we would say that B equals 7 degrees. That's the angle, so that when you take the tangent of it, you'll get 0.1288 as the answer. Now again, if you go tan of 7, it's not going to be 0.1288 because we rounded our angle. To check with the exact answer we got, we'll take the tangent of the previous answer. And you get the 0.1288. So this is a check that you can do to make sure your answer is correct. Make sure you did things correctly. Question C, if you're told that the cosine of theta, so that's just a Greek letter, theta, that's often used to represent an angle. We've seen that symbol before. But if the cosine of theta is 0.2561, and you want to find out what angle theta is, we'll do cos to the negative 1 of 0.2561. So second function cos of 0.2561 tells us the angle to the nearest degree is 75 degrees. So theta is approximately 75 degrees. And to check it, if we take the cosine of the angle that's in our calculator, cosine of the previous answer, we'll get exactly that decimal point 2561. So for the last one then, you're told the tangent of gamma, that's a Greek letter gamma, is 1.4985. To find out what gamma is, we will go second function tangent, or tan to the negative 1 of 1.4985. And that'll tell us what the angle gamma is that we will round to the nearest degree, so it's an approximate answer. So second function tan of 985. So to the nearest degree, approximately 56 degrees. So again, if I round that to 56 and I check the tan of 56, it won't be exactly 1.4985. It'll be close, but not exact. If I want to check it, I should use the entire decimal, and you'll get the right 1.4985. And if you don't know how to use the previous answer function on your calculator, just type it all in. Tan of 56.28346,995. Type the entire decimal in, and you do get the right answer, 1.4985. Okay? So, this is how we use the calculator to find an angle if you know what the sine or cos of the tangent of an angle is as a decimal. That's how you use a calculator to find out what the angle is. So now we'll apply that to finding missing angles in right triangles. Remember, to use SOHCAHTOA, you must have a right triangle. You've got to have a 90-degree angle in it, because the first step is to label the sides. The side across from the right angle is the hypotenuse. This is no different than what we did before. Only now we're trying to find an angle, but that's still the angle that you're working with. You want to find out what that angle S is. That's the angle we're trying to find, so the side across from that is the opposite. The third side is left to be the adjacent. So this is no different than what we did before, except instead of giving an angle, you're finding an angle. But the side across the angle you're looking for is the angle you're working with. The side across is the opposite. So now in this case, you're given the hypotenuse and the adjacent. You're not given the opposite, not asked to find it, not going to use it. SOHCAHTOA tells us which ratio uses the opposite and the adjacent, and that is the adjacent and hypotenuse. Adjacent and hypotenuse, that's the cosine ratio. That's what the COP part tells us. So now we need to write our equation. The cosine of the angle, which is what we're trying to find, angle S, equals, and the definition tells us that cosine is A first, H second. Adjacent on top, hypotenuse on the bottom. Adjacent is 103.5 divided by the hypotenuse, which is 185.7. It must be in this order. You'll actually get an error if you try and figure out with having these two numbers switched around. You won't get any answer in your calculator. So to find out what angle S is, this is really not much different than what we did above. The only difference is above we were given what the sine, cos, or tan was as a decimal. In this case, we're given what the cosine is as a fraction. But we do it exactly the same way. If the cosine of S is this fraction, to find out what angle S is, we go second function cos, and we put that fraction in our calculator. 103.5 divided by 185.7. You see, you can find out what this is as a decimal first, if you want, by just dividing those two numbers. And then it's exactly the same as what we have above. We were told what the sine of A was as a decimal, so we went second function sine of that decimal to get our angle. The only difference here is instead of a decimal, we're given what the cosine of S is as a fraction. So we can put it in as a fraction. We'll get the answer. So to the nearest degree, it's 56 degrees. That's what angle S is, 56 degrees. So again, this is how we find a missing angle in a right triangle. The first few steps are no different than what we've been doing all along. Label the sides. Circle the sides that you're going to use. Write your equation. Only now you're trying to find the angle instead of given the angle. And the only big difference is that you're going to go second function. You're using the second function buttons in your calculator to get sine to the -1, cos to the -1, or tan to the -1. Okay, question B. We want to find the measure of angle B. That's where the question mark is. That's what we're trying to find. But we start by labeling the sides of the triangle. Side across from the right angle is the hypotenuse. We're trying to find angle B, so the side across from that is the opposite. Third side is the adjacent. In this case, we're going to use the opposite and the adjacent. Those are the two sides we're given. Just so happens they are the same measure in this case, but that doesn't matter. Those are the two sides we're given. Those are the two sides we're going to use. We're not given the hypotenuse, not going to use it. And if we look at SOHCAHTOA, the TOA part tells us that tangent uses opposite and adjacent. And normally the order matters, O on top, A on the bottom. In this case, because they're the same number, it actually wouldn't matter. But to do things correctly, we would say the tangent of angle B equals opposite of 34.8 divided by the adjacent of 34.8. And then to find out what angle B is, we'll go second function tangent of that decimal. And we're going to get an answer for this one that we won't have to round. We're going to get exactly 45 degrees. So it's actually not an approximate answer, it's exactly 45 degrees. Remember I said on the last one, if you switch the 103.5 and the 185.7 around, if you put the 185.7 on the top, you'd get an error in your calculator. I'll just show you that that actually does work. 185.7 divided by 103.5, you get an error. And the reason for that is the sine and cosine of every angle will be a decimal between 0 and 1. If you switch the 185.7 and the 103.5 around, and you have the 185.7 on top, and you divide by 103.5, you're going to get a decimal greater than 1. But the sine and cosine of every angle is a decimal between 0 and 1. So that's why you get an error if you do that. Okay, looking at question C. We always start by labeling the sides of the triangle. Side across from right angle is the hypotenuse. You want to find angle here, E here, So the side across from that is the opposite. Third side is the adjacent. So this is no different than what we've been doing, except instead of being given an angle, we're trying to find an angle. In this case, we're going to use the opposite and the hypotenuse. Those are the two sides that we're given. And SOHCAHTOA tells us that the sine ratio uses opposite and hypotenuse. That's the SO part. And so we'll write our equation. The sine of the angle E equals, and the order matters, it's opposite over hypotenuse. Again, if you switch these two around, if you put the 0.63 on top and divide by 0.45, you're going to get a decimal greater than 1, and it won't work. You'll get an error. The sine and cosine of every angle is a decimal between 0 and 1. Tangent, though, can be greater than 1. We saw that above, where we had the tangent of gamma equaling 1.4985. We got an answer, 56 degrees. But not for sine and cos. They have to be decimals between 0 and 1. So, to find out what angle E is, we go second function sine and put that fraction in 0.45 divided by 0.63. So if I round that to the nearest degree, that would be 46 degrees. So there's the approximate answer for what angle E, the missing angle, is. All right, question D. You want to find the measure of angle A. That's where the question mark is. But we start by labeling the side. Side across from right angle is the hypotenuse. Because you want to find angle A, the side across from that's the opposite. Third side is the adjacent side. In this case, we're going to use the opposite and the adjacent. Those are the two sides we're given. We're not given the hypotenuse, not asked to find it. And SOHCAHTOA tells us that the tangent uses opposite and adjacent. The tangent of angle A, the TOA part tells us that it's opposite first, adjacent second. Opposite on top, adjacent on the bottom. And again, because it's tangent, it doesn't necessarily mean that the top number has to be smaller than the bottom number, because the tangent of an angle can be greater than 1. Just so happens in this case it's not a decimal greater than 1 because the top number is smaller than the bottom. But you have to follow the order that the SOHCAHTOA tells you. Tangent is opposite first, adjacent second. Opposite on top, adjacent on the bottom. So to find out what angle A is in, it's second function tan of 4.5 divided by 8.6. So that would be rounded to 28 degrees. There's the approximate answer for angle A. Now again, you can always look at your answer and make sure it's reasonable. The smallest angle has to be across from the smallest side, right? If we look at the two sides we're given, the opposite side is the smallest side, and it will be the smallest side of this triangle because the hypotenuse is always the longest side. So angle A has to be the smallest angle in the triangle. We've already got one angle of 90 degrees down in the bottom right. We're saying this top angle is 28 degrees. Remember also that the three angles of every triangle add up to 180, always. So if one angle is 90, the other two must add up to be 90 as well. We could find B by going 90 minus 28. We're not asked to find angle B, but we could get it quite easily. That would be 62 degrees. And this just confirms that angle A is the smallest angle in the triangle, which we got. 28 degrees, that's the smallest angle in the triangle. It's across from the shortest side. All right, so if we look at these again, find the measure of the indicated angle, round to the nearest degree. These triangles are not labeled, except they're just labeled with what angle you're looking for. So we'll choose our variable. Let's say we'll use the variable theta, the Greek letter theta. You can use a letter if you want. Write an A there, it doesn't matter. But we start by labeling the sides of the triangle. Side across from the right angle is the hypotenuse. We want to find angle theta, so the side across from that is the opposite. Third side is the adjacent side. In this case, we're using the opposite and the adjacent. SOHCAHTOA tells us what ratio uses only those two sides. That's the TOA part. Tangent is opposite first, adjacent second. The tangent of the angle theta will be opposite on top, adjacent on the bottom. So to find out what theta is, it's second function tangent of 12.9 over 13.8. So rounded to the nearest degree, that would be 43 degrees. Right? If we went and found the measure of the other angle, it would be 47. It would be 90 take away 43. Those two angles are close together. And they would be because the two sides that we're given are close together as well. Because the two sides are close together, the angles across from them will also be close together. Okay, try B on your own, and then we'll check it. This assignment was taken in from March for slope. These are the review notes that we went through in class. So if you look on Google Classroom, you'll find the video where we went through this whole thing, and that's the assignment that we wanted to do. Okay, so we start by labeling the sides of the triangle. We want to find this angle up at the top. So we'll let that be theta. The side across from the right angle is the hypotenuse. Side across from the angle we're looking for is the opposite. Third side is the adjacent. So in this case, we're using the adjacent and the hypotenuse. We're not given the opposite, not asked to find it. And SOHCAHTOA tells us that the cosine uses the adjacent and the hypotenuse. That's the ka part of SOHCAHTOA. The cosine of the angle must be adjacent first, hypotenuse second. Adjacent on top, hypotenuse on the bottom. So the cosine of theta is adjacent, which is 2.3, over hypotenuse, which is 3.5. Because it's cosine, the smaller number must be on top. It would be the same thing if it was sine. The smaller number must be on top because the decimal has to be between 0 and 1. 2.3 is smaller than 3.5. So to find out what theta is, it's second function cosine of 2.3 divided by 3.5. So rounded to the nearest degree, that would be approximately 49 degrees. So that's what you should have got for that one. 49 degrees. Okay, try that next one on your own, and then we'll check it. Want to find angle A. So the side across from the right angle is the hypotenuse. Side across from the angle we're looking for is the opposite. Third side is the adjacent. In this case, we're using the opposite and the hypotenuse. We're not given the adjacent, not asked to find it. And SOHCAHTOA tells us that the sine ratio uses opposite and hypotenuse. So the sine of the angle theta, and again, the order matters. It has to be opposite on top, hypotenuse on the bottom. The SO part tells us it's opposite first, hypotenuse second. Opposite on top, hypotenuse on the bottom. Also, the bigger number has to be on the bottom. You can't have the bigger number on top. If you reverse those and go 10 divided by 2, you're going to get the sine of theta equal positive 5. And when you go second function sine of 5, or 10 over 2, you'll get an error. The sine and cos of every angle is a decimal between 0 and 1. So second function sine of 2 divided by 10 tells us that the angle to the nearest degree would be 12 degrees. Okay, now for question D, we want to find both x and y. It doesn't matter which one you start with. So let's say we're going to find x first. If we label the sides of the triangle, the hypotenuse is the side across from the right angle. If we're looking for angle x first, the side across from that is the opposite. The third side is the adjacent side. So in this case here, we're using the opposite and the adjacent. We're not given the hypotenuse, not asked to find it. And the SOHCAHTOA tells us that the tangent uses opposite and adjacent. The tangent of x degrees equals, and the TOA tells us that it's opposite first, adjacent second. Opposite on top, adjacent on the bottom. To find out what angle x is, it's second function tan of 23 over 31. If you reverse these, you wouldn't get an error because the tangent can be greater than 0, better than 1, I should say. But you get the wrong answer if you reverse them. TOA tells you that it's opposite first, adjacent second. Opposite on top, adjacent on the bottom. So if we round that to the nearest degree, that would be approximately 37 degrees. And you don't have to use a trig ratio to find out what angle y is. Remember we said the three angles of every triangle add up to 90 degrees always. If you've already got one angle at 90, what do the other angles add up to, Thomas? No. If one angle adds up to 90 degrees, the other two angles must also add up to 90 degrees. So x plus y have to add up to 90. That'll give you a total of 180. So if we want to find angle y, we can find it by simply going 90 take away x, which was 37. So what is that? 43 degrees? 53, sorry. 53 degrees would be the measure of angle y. So you don't have to use SOHCAHTOA to find the third angle of a triangle if you have the other two. We could have found y first using SOHCAHTOA, and we would have got 53 degrees. And that would have made x 90 minus 53, which is your 37. Okay? So it doesn't matter what order you do these in, you'll always get the right answer if you do it correctly. Again, remember, we never use the 90-degree angle in our equation. Okay? Never. It has to be one of the smaller angles, the angles between 0 and 90. Okay, so we'll stop there. I'll hand out the assignment. This assignment, the answers will be posted on Google Classroom, so you can check your work. Remember, the one from yesterday needs to be handed in. If you didn't hand it in already, you should be finishing that off and getting